Hi guys, how you doing? I just wanted to actually explain a couple concepts just about R squared and R, show an app that just kind of might ex, help you understand and just go over the workbook stuff in a slower pace. So first of all, let's just talk about a least square regression line. And right here, let's say we have these points right here. So you notice right here, my X values, which is my explanatory variable, is increasing slightly and pretty steadily though. And the Y, the response variable is decreasing right here pretty steadily. Okay. So right here we have 12, and this is 1243, 2342, 4532, 5620, 7710, 785, 991, and 1130. All right, so we're going to put all of this in, and I'm going to show this instead of showing in a calculator, I'm going to show it in an applet. Here we go. So here we have it, 1243, 2342, 4532, 5620, 7710, 785, 991, 1130. So right here, I make a scatter plot, and here it is. As you can see, this is actually a really solid least square regression line. Notice how tight these points are. The residuals are very small. All right, they're minimal right here, these residuals. Looks like the highest one I have is right here and that would be about 80. Now we can look at the residual plot to see. The only other contender, I guess, would be maybe the one that's right here. Actually, looks like a pretty big one. That would be at, I don't know, about 116. So either about 79 and 116 are probably the highest residuals. Let's see. Now here is the residual plot. So we said that the highest one would be at either 116 or maybe at about 79. Let's see here. 79. Yep, that is a pretty big one. There it is right there. 116, that looks like a pretty big one. So those are the two highest residuals. So this is the residual plot. And remember, the residual is essentially, residual is just kind of like a, let's call it like kind of like an error. It is right here with this least square regression line, we are guessing. That's a prediction. These blue points right here are actual. So a residual is just the actual minus the guess, actual minus prediction. So right here, that's why that residual right there, I can't write on this, but this residual right here and this residual right here are going to be the highest ones. And we can see that from the residual plot. Yeah, there it is right there to the 79. That's pretty high. It looks like it's at -6. And the other one at 119 is pretty high too. That looks like it's about 5 or something like that. So these are the two highest residuals right there. The other ones are pretty tight. And this shows, remember, that this is an overall, this residual plot, since we have points equally spread right here with no obviously pattern. There's not really any pattern right here. And they're equally spread. That shows us that a linear model is appropriate, and we can go ahead and do a least square regression line. If we had some type of curved pattern, then we would say a linear model is not appropriate. We would, then we would not use a least square regression line. All right, so let's look at the correlation right here. The correlation, R. Remember right here, this shows the direction and the strength right here. So the direction is obviously negative. Of course, it's going downwards. The strength, the closer it is to 1, the stronger. The closer it is to 0, the weaker. And if it's at 0.5, consider it moderate. So this is strong and negative right here, this correlation. Okay, so and it gives us right here also the R squared value, which is also pretty high. So R squared is, if we rounded that to a percent, 95%. So remember what R squared does. R squared gives us the percent of the variation in the response variable accounted for by the least square regression line. All right, that's basically shown by the least square regression line. That's what accounted for means. So 95% of the variation in the response variable, I just called it Y right here, but you can call it whatever you want. I mean, you can put whatever response variable you want to right here. I just call in this case, Y, is is, or you can say represented or accounted for by the least square regression line, with x equals, and then put x in context. S is the standard deviation of the residual, and this is the average distance of each residual. And what is a residual? That's the actual minus predicted. So overall, it is the average distance between the actual data value and the predicted data value of y, whatever y is. Okay, so the actual value of y and predicted value of y. And this gives us the actual least square regression line right here. Okay, so right here. So that's fine. So let's do an experiment here. Let's give ourselves a huge outlier. So right here, I'm going to change this 32 right here. I'm going to change that to 2. Okay, so that means that right here at 45, which is right here, this value is going to be all the way down here, giving us a big residual, a large residual, I should say. So let's go do a begin analysis. Okay, yes, it will change right here. Okay, so we had both a really strong correlation. It was strong and negative. And remember, our R squared value was, I forgot what it was, I think it was 95%. So let's take a look now. Now, okay, still have a somewhat strong R value, but I think it was very close to -1 before, and I think it was actually 95, right? Negative 0.95. So now it's a little different, okay? It's negative 0.85, so it's a little less strong, so that affected it a little bit. Let's take a look at okay, so now look right here. Before we had an R squared that was, I think it was 0.94 or something like that. Now it's down to 0.72. So what does this tell us right now? This tells us the higher the residual, the lower the R squared. And obviously the higher the S, because S is just the average value of the residual. So S went up, R squared went down. Okay, so right here. And then you can see this residual reflected right here. So just to sum all this up right here. As the residuals increase, what happens right here? So if you increase a residual, remember that means that right here, let's say we have one line that doesn't really have very much residuals at all. And then we have another line that right here, we're going to go and add a couple residuals right here. So if the residuals increase right here, so I added a couple residual, what's going to happen right here? Well, I'll tell you what's going to happen. R squared will go down. Oops, sorry. Will go down. R squared will decrease. And why is that? Because right here, it's the percent of variation that is accounted for by the least square regression line. Well, now right here, if you have very high residuals, this variation isn't so much accounted for by this least square regression line because we don't have as tight a residuals anymore. So R squared will go down, and obviously S, which is just the average value of each residual, S will go up. Okay? So as the residuals increase, you have two things that are going to happen. R squared is going to go down, and S will go up. Okay? R squared basically, in essence, tells us how good is this least square regression line. That's not the interpretation, but I'm just, just in general, that's what it is. Well, right here, if we have higher residuals, that's not so good. Okay? So it will go down right here. And S right here, of course, will go up. All right, I hope that kind of cleared a couple things up right here. So I'm going to go and do another video of the workbook information so you have a separate video.